Hello guys, welcome to Crown Smart. In this video we're going to talk about function. Okay, a function is simply a maps that map the set the element in the set A to the element in the set B. Okay, now the set A is known as the domain, while the second one is the codomain. Now observe that this is the set A. Now these are the elements X, Y, Z, and these are the elements in the codomain f of x, f of y, f of z. Now reason why we denote this as f of x is that observe that x is being assigned to f of x, so the image or the element in B is called the image of the element in A if the element in A is being assigned to that element in B. So f of x is being assigned to f of x, so we call f of x the image of x. The same thing applies here. We call it the image of y, and this is the image of what? Z. So that's what a function is. We can have other examples where we have let's say this is x. I have 1 2 3 4. I have another one, I call it y. Okay, now let's call this function g. G mapping x to y, that is g maps x to y. Now let's say this is a b c. Now observe that 1 can go to this, 2 can also go to A, this go to this go to this. Simply, a function simply means it's a map that maps elements in the domain to the unique elements in the codomain. It's simply mapping elements in the domain to a unique element in the codomain. When you say something is unique, it means something is just one. Okay, now there are different ways to know if this is a function. Okay, now the first thing first is to know that, let's say given x, okay, and you have a function f and you're mapping it to y. Okay, now the first thing to note is that every element in the domain must be assigned to what element in the codomain, to some element in the not just some, to a unique element in the codomain. Now look at this now, so that every element is being assigned to a unique element in the codomain. Take this as the son, take this as the father. Observe that a here can be a father of two sons here. Let's say this is the first son, this is the second son, so A can be a father of two sons, which is possible. This can be a father of this can be a father of this, okay, which is possible. Now assuming I have this, let's say we have 1 2 and 3. I have A B C. Now look at this, okay. Now observe that I did not assign 3 to anything. Okay, now observe that you can't have a son without a father, so it's not possible. So if this is the son, this is the father, you can't have a son without having a father, so this is not a function. Okay, another case is when, let's say you have this as 1 2 3 4, and you have this as a b c d. You take this as your x, take this as your y. Let's say this is a function f. Now let's say 1 go to this, the same 1 go to B, 2 go to C, 3 go to D, 4 goes to A. Okay, now observe that one of them is being assigned to two elements here, whereas our definition says that it must be assigned to a unique element in a codomain. Now 1 is being assigned to A and B. You see that this makes this not a function. Reason is because a son cannot have two fathers. It's not possible for a son to have two fathers, so it's not a function. Okay, so we can also have case where let's take this as x, let's take this as your y. I'm just giving cases where you might have this as a function and have it as not a function. Now let's say you have a b c. assigned to A, B, C. Okay, observe that this element is being mapped to itself. Now this is a function, and such function we call it the identity function, and it is denoted as f of x equal to x. So such function like this is called the identity function. Reason is being mapped to itself. Okay, in one of our videos I'm going to explain further about what an identity function is. Okay, another function you might have here is let's call this A, B, C. Let's say 1, 2, and let's call this 3. Now observe that every element here are being sent or assigned to a unique element in the codomain, and just one element here. Observe that I did not assign any element to this other two. So far as every element here is being assigned to the codomain, to a unique element in the codomain, is a function. Now this is also called a constant function, which is denoted as f of x is equal to what? C. Okay, now this is where every element in the domain this is where every element in a domain still gives us a constant value. Okay, no matter the value of any value I put here, I still get what? A constant value. An example, a typical example is when you have f of x equal to 2. No matter the value of x I put here, let us say f of 1, I still get my value as 2. No matter the value, f of 2, f of 3, no matter the value of x, I still maintain my value of 2. In my next video, I'm going to explain what a constant function and an identity function is. Now all these are just to let you know how a function looks like. Okay, also we are going to explain more on range of a function. Actually, we are not just going to go deeper, but just explain the concept of range. Now range simply means there are sets of elements in the codomain that are being assigned to elements in the domain. Now for instance, let's call this x, let's call this y. Now if I have here a, b, c, d, I have here as 1, 2, 3, 4. You can create so many examples. I'm just using this to illustrate how a function looks like. Okay, now let's say 1 is being assigned to a, 2 is being assigned to b, 3 is being assigned to d, and 4 is being assigned to c. Okay, let me extend this. Let me extend this to e. Now the range here is just a set. Okay, is a set containing elements that are being mapped from the domain to the to the codomain. So those sets of elements are, let me denote the range as f of capital Y, which is defined as the collection of f of small x, okay, such that x is coming from. Okay, so I can say this as, now what is the range? Now 1 is mapped to a, so a is an element. I can take a, b, c, and d. So this is the range actually. Okay, so the range are those outputs, okay, giving the inputs. So an example, a typical example is, let's say we have a set of values 1, 2, and 3. Okay, let's have this as set x, set y. Now let's call this our function, and let's define this our function to be our f of x to be 2x. Now if x is 1, then our f of 1 is simply 2 times 1, which gives us 2. So 1 maps to 2. Now if x is 2, we have f of 2, which gives us 2 bracket 2 is equal to 4. That is 2 times 2, 4. Now if f is 3, f of 3, we have 2 bracket 3, we have 2 times 3, 6. So we have 6, and so on and so forth. But these are the given values given in the in the domain. So we have that our range is simply 2, 4, and 6. The set containing 2, 4, and 6. So that is our range. Now observe that the range here is equal to what? The codomain. The range is the same thing as the codomain, so definitely our range is simply the set 246. So in our next video we are going to talk about domain and range. So I would like you guys to subscribe to this channel. Please do not forget, watch this video very well and subscribe to this channel. Really, thank you very much and God bless you.